Good morning, all of you. For the today's session, we are going to solve practice set 2.3. So, what exactly is the specialty of the practice set 2.3? This practice set 2.3 is the solution. This method is for the solving roots of a quadratic equation with the help of completing square method. That is very important. Completing square method, this is very important. So why it is a name of this particular method is given as a completing square method, because in that particular method, while solving that quadratic equation, we used to get a complete square. So that's the reason why this particular method is named as a completing square method. So how to solve that particular with the help of completing square method, means how to solve that quadratic equation, those different kind of quadratic equation with the help of completing square method, that we'll see for the today's session. So let's take a first example. Here we have example number one. What is example number one? In example number one of that practice set 2.3, that example is x square plus x minus 20 will be is equal to 0. You may say that, sir, we can solve this problem with the help of factors, but we need to find out multiplication of the two number and then addition of two number, then find out those, just gauge those two numbers, and then those will be the roots of that particular quadratic equation. That is little tiresome, and every time we need to think more. So this is a method. This method is quite easy and very easy kind of method. With this method, we can easily, with a less step, we can solve our problem, right? So maybe the step will be to get increased, but we don't want to think about addition of two numbers and multiplication of the two numbers. So that that particular thing in the factorization method, that is get, we are going to skip it over here. So we don't want to use that method. So this is another method. So what that method is, so just we are going to solve with the help of that method. Now what to do? Always try to keep a constant on the right hand side. Here we have a constant, that is minus 20. Keep it on a right hand side. So what to do? I'm writing that equation again, that is x square plus x minus 20 will be is equals to 0. So what I'm just going to do, if here is a minus 20, add plus 20 on both sides. Add plus 20 on both sides. So what will going to happen? What will happen after adding the 20 on both sides? So x square will be remains as it is, plus x will remain as it is, minus 20 plus 20, it will become 0, will be is equals to 0 plus 20, it will become a 20. So now our constant is get shifted to the right hand side by just adding plus 20. If it is here minus 20, instead of minus 20, if it is there plus 20, then you need to subtract 20 from the both terms. So that is a easy way to get a constant on the right hand side. So that is what is next step, that is x square plus x will be is equals to 20, right? So what is the coefficient of x over here? The coefficient of x here, nothing is there. That means what it is? That is nothing but a 1. Just write that 1 over there. So that is very next important step, right? Just after just we can say that taking that coefficient, divide it by 2, divide by it by 2, or other you can multiply by 1 by 2, right? So I'm just dividing it by 2, right? So by dividing 2 and making it square, how what it will be, I'm just writing as it is. So add that square on the this particular equation that we got over here. So x square I'm writing as it is, plus x I'm writing, and now I'm going to add equal to 20, I'm going to write them as it is, and I'm going to add 1 by 2 bracket square, right, that on a both sides. So 1 by 2 whole bracket square I'm writing over there, 1 by 2 bracket square I'm adding on a both side, right? So what is our next step now, right? Our next step is just make a one bracket. So this will be in what form? This particular left hand side, this is nothing but a x square plus bx plus c will be is equals to what? A plus b bracket square. Sorry, that is nothing. It is nothing but a square of a which term. So we have x square plus bx plus c. So that is nothing but a, what it is exactly? It is a square of a which term? It is a square of a, we can say that x plus uh, uh, x plus something, we have x plus something there will be there, right? So instead of this, what I'm just going to do, this particular left hand side, let's focus on the first of all left hand side. So what we have on the on the left hand side we have square term, left hand side we have a the term whose power is 1, and we have a constant. So this will be nothing but a x plus 1 by 2 whole bracket square. If I just split this particular bracket, so what I'll get, if I just split x plus 1 by 2 bracket square, what exactly I will get? That is nothing but x square 2 times of first term into second term, right? Plus we can say that the square of the last term, the second term, right? Second, this 1 by 2, right? So x square plus this 2 will get cancelled, that will become x, plus 1 by 2 square will be 1 by 2 square. So instead of we can say that instead of x square plus x and 1 by 2 square, what I got a complete square, that is x plus 1 by 2 bracket square. So this is nothing but a completing square method. That's the reason why it is called as a completing square method. So this whole term can be replaced by this particular term. So every time, no need to just write this particular two steps. So better take a variable, take a variable and take a constant over there and make the square of that particular term, right? Okay, bracket square, right? So 20 plus 1 by 2 square, that means 1 by 4. Here we have x plus 1 by 2 bracket square as it is, right? So cross multiply it. So nothing is there, that means that is nothing but a 20. So how to cross multiply it? So this is very easy, 20 by 1. This is very basic, right? Cross multiply means, that means we need to multiply these two numbers. 24 is 80, right? Plus sign, that is a plus sign. Then this 1 into 1, that is nothing but 1 into 1, 1 divided by this 1 into 4. 1 into 4, 4 ones are 4, right? So 80 plus 1, that is nothing but 81 by 4. So we got 81 by 4, right? So we got a complete square here. So what to do? Now take a square root on both sides. Let's take taking square root on both sides. Taking square root on both sides. So what exactly you will get? By taking square root on both sides, you will get a next term. So what is that next term? Is square root of a x plus 1 by 2 whole bracket square will be is equal to plus minus. While taking a square root, take a plus minus, because this square of a minus 2 will be is equal to again plus 4, and square root of plus 2, that will be also equal to plus 4. So that's the reason why square root of 4 can be written as plus minus 2. So that is the why I just took a plus minus sign over there, right? So it is quite easy. Okay, now, so why I took a plus minus sign, that I explain right now. So square root of the right hand side, that is nothing but a 81 by 4. Square root of a, we can say that 81 by 4. So right now in the next step, this square term and this square root will get cancelled. What will remain over there? That is nothing but x plus 1 by 2 will be is equals to plus minus square root of 81. 9 9s are 81. So square root of 81 is nothing but a 9. Square root of 4 is nothing but a 2. So we got a plus minus 9 by 2. So now what will remain over there? Here we have x plus 1 by 2. Okay, I'll remove the bracket. So x plus 1 by 2 will be there, that is plus minus 9 by 2, right? So what to do? Just if it is here, I want only x on this particular set. So what I'm just going to do, I'm going to subtract 1 by 2, because plus 1 by 2 minus 1 by 2 will get cancelled. Again I'm going to subtract 1 by 2 from this particular term. So what will happen? What will be the next step, right? So that will be x plus minus 1 by 2, that is nothing but a 0, plus 0 will be is equal to plus minus 9 by 2 minus 1 by 2. So because I'm subtracting this minus 1 this 1 by 2 from this term, right? So what will remain on the left hand side? X, or we got on the remain on the left hand side. So what is there? That is I'm going to take a plus 9 by 2 minus 1 by 2 in the first term, that is a plus 9 by 2 minus 1 by 2 in first term, or we can say that x will be is equals to, now we can take a minus 9 by 2 minus 1 by 2 will be remain as it is, right? So we got the two values of this particular x. So that means that this is nothing but a roots of the quadratic equation. Simplify this. So what we will get? X will be is equals to denominator are same. That's the reason why. If the denominators are same, then numerators are get added or subtracted. So plus 9 minus 1 divided by 2, or x will be is equals to minus 9 minus 1 divided by 2, right? So we have x will be is equals to 9 minus 1, that is 8 by 2, or we can say that here minus 9 minus 1, that is equals to minus 10 by 2. So x will be is equal to 2 1s are 2, 2 4s are 8. So we got the first root of that quadratic equation, that is x equals to plus 4, and x is equals to 2 5s are 10, but there is a minus 10. That's the reason why x is equals to 4 and x is equals to minus 5 over there. So we got the solution. We got the root of that quadratic equation. That is nothing but a x will be is equals to 4 and x is equals to minus 5. So this is the solution of the first problem. Now let's move towards second problem. So what is the second problem in the that particular practice set? Second problem is equals to x square plus twice x minus 5, right? Let's move towards next problem. Okay, I'm just moving towards next problem. Now what is the next problem? That is x square plus twice x minus 5 will be is equals to 0. So this is also same method. What to do? Take a constant on the right hand side. How to take a constant on the right hand side? If it is a minus 5, then add a plus 5 over here. Add plus 5 on the both side of this particular equation. Now by adding the plus 5 on the both equation, right, both side of the equation, right? So what will remain over here? X square plus twice x. This minus 5 plus 5 will become 0, will be is equal to 0 plus 5 will be is equal to plus 5. Now what will remain over there? That is x square plus twice x will be is equal to plus 5. Now we shifted our constant to this side by just adding a plus 5. If it is here instead of minus 5, if it is a plus 5 is there, if it would be there, then what we need to do? Then subtract 5 over there, right? So that is quite good. Now what is the constant, what is the coefficient of x here? That is very important, coefficient of x, right? So that is the first attempt. That is coefficient of x is equals to, here we have, that is equals to 2. Now divide it by 2, divide by it 2, and then square of this, take a square of this particular term, right? So by squaring this particular term, and what is our next step now? Keep a x square plus twice x as it is, add that square term on both side of that particular equation, right? So 2 by 2 will be remain as it is, that is equals to its square we have, that is equals to 5 plus 2 by 2, that is nothing but a 1. It will be there, definitely it is a 1. I'm going to write down that term again, that is 1 x square plus twice x plus 1 square, that means 1 will be is equals to 5 plus 1 or 2 by 2, that is 1 square, that is nothing but a 1, right? So what is this? This is a complete square. What that square it is? It is nothing but a x plus 1 bracket square, right? This, instead of this x square plus twice x plus 1, I can replace it by the x plus 1 bracket square, will be is equal to now 6, right? Will be is equals to, now we got a 6, right? So you may say that how could we just conclude that instead of x square plus twice x plus 1, why I am just going to place x plus 1 bracket square? It is a complete square. You can simplify it, you will get an answer, right? If you just expand this x plus 1 bracket square, you will get the same term, that is first term square plus 2 times of first term into second term plus second term square, right? So that is nothing but a x square plus twice x plus 1. So instead of x square plus twice x plus 1, we can place it by a x square plus 1 x plus 1 bracket square, right? So taking square root on both sides. Next step is taking square root on both sides. So take a square root on both sides. What is going to happen? I'm writing that x plus 1 bracket square as it is, right? I'm now going to take a square root on both sides, will be is equal to plus minus. That is very important step. While taking square root on both sides, you need to write the plus minus sign before the constant, right? So square and square root will get cancelled. What will remain over there? Only x plus 1 will remain there, that is equals to plus minus root 6. So what is our next step? Right? So x plus 1 I'm writing as it is. I'm removing that bracket. X plus 1 plus minus square root of 6. So what is that? Take this. Now we don't want a 1. We don't want it 1 over there. So here we have plus 1. I'm going to subtract 1 on both side of the equation. Right. So what will going to happen? X will be remain as it is. Plus 1 minus 1. It will be become 0. Will be is equal to plus minus root 6 minus 1. Now what is our next step? Right, our next step will be is equals to what will remain over there, that is nothing but only x will be is equals to, I'm going to take a plus root 6 first and then minus 1, or now I'm going to take a minus of x will be is equals to minus of root 6 and then minus 1, right, because here we have plus and minus two terms. So plus 6 plus root 6 I'll take first and then I'll write down this first term is nothing but a value of x, then later on this minus x minus of root 6 and then minus 1, like that I will write down. So I got these two terms. So this is what this is, these are nothing but a roots of a quadratic equation, right. This is very easy method, right, it is quite easy method. Now let's move towards our third problem. Third problem is also interesting, right. Okay, so what is the third problem here we have? Let's make a room for the this next problem. Okay, third problem. So third problem of this parity set. So that is what it is. That is nothing but a m square minus 5m minus 3, right. So will be is equal to 0, right. Will be is equal to, oh sorry, no, it is not like that. Wait, I just made a mistake. Here we have what we have, m square. Directly they provided you what they provided you, m square minus 5m will be is equals to minus 3. So no, our first step of just taking a constant on the right hand side, that they have already gave to you ready made, they gave you ready made that minus 3 on the right hand side. So let's concentrate on what, concentrate on the coefficient of uh, a term whose power is 1. So coefficient of plus m is equal, coefficient of m is equal to what, coefficient of m will be is equals to minus 5. Now divided by 2. So minus 5 I'm going to divide it by 2 and take a square and take a square, right. So why, what to do now, add this square term in the left hand and right hand side. So I'm writing that m square minus 5m. I'm now going to add that minus 5 by 2 whole bracket square on the both sides. This minus 3 will be there. I'm adding that minus 5 by 2 whole bracket square on the both sides. So what this is, this is complete square. What this complete square is nothing but a, this is nothing but a m minus 5 by 2 whole bracket square. So what I took m from here, I took this constant from here, and I whatever the constant it is at minus 5 by 2, and I took a bracket square. If you simplify this bracket again, you will get this term, right. So that will be is equals to minus 3. Now here you can take a square. No need to take a square, no need to make a square of this particular one. It is better to keep as it is, but on the right hand side you can keep a square, because here we have constant and we can add subtract, right. So minus 5 square, that is nothing but a plus 25, plus 2 square, that is nothing but a 4. So 5 square 25 plus 2 square, that is equals to plus 4, right. You may say that, sir, why minus 5 square is nothing but a 25? Minus 5 square means multiplying on both number, right? Multiplying same number on the two times, right. Minus plus 5 5s are 25. That's the reason why minus 5 square is nothing but a 25 plus 25. Okay, now you can cross multiply this. So how to cross multiply this, right? So by now in order to cross multiply this, I'm just need to certain place, okay, space over there, right. So what is there, minus 3 plus 25 by 4. Now in the denominator of 3 nothing is there, that means 1. Now cross multiply this, just multiply this, minus 3 into 4 minus 12. Now plus sign, because that sign is plus in between two fractions, right. So and then now multiply this, 1 into 25, 25 ones are 25 divided by, now this 1 and 4, right. What it is, that is nothing, 1 4 the 4. Now 25 minus 12, 25 minus 12 is nothing but a plus 13, right, divided by 4. Now we got the, this equation is nothing but a plus 13 by 4 on this particular side. So m minus 5 by 2 whole bracket square is equals to, we got plus 13 by 4. Now what is our next step? Take a square root on both sides. Next step is take square root on both sides. Take square root on both sides, right? So how to take a square root, right? So take a square root on both sides. I'm just writing that bracket minus m minus 5 by 2 whole bracket square will be equals to plus minus. That is, no need to forget that plus minus, and that is very important. That is root 13 by 4, right? So square and square root will get cancelled. This square and this square root will get cancelled. What will remain over there? M minus 5 by 2 will remain as it is, will be equal to plus minus root of 13, and square root of 4 is nothing but a 2, right? But we don't need to write down. 13 is not a complete square, so we are keeping as it is in a that square root sign, right? So what to do? I don't want this minus 5 by 2, so what I'm just going to do, I'm going to add plus 5 by 2. If it is a plus 5 by 2, I need to subtract. If it is a minus 5 by 2, then I need to add plus 5 by 2 over there, right? So plus 5 by 2 on the both side, right? Now what is the next step? This m will be remain as it is. Minus 5 by 2 plus 5 by 2 will become 0, will be is equals to this plus minus root 13 by 2, right? Plus 5 by 2 will be remain as it is. Now what is our next step? What is our next step? What will remain over there? M will be remain over there, right? So m will be is equals to plus minus root 13 by 2. Now I'm going to take a plus root 13 divided by 2 plus 5 by 2, and then now I'm going to take, or m will be is equal to next term, that is minus of root 13 by 2 plus 5 by 2. So this is denominator are same, then numerators are get added, then root 13 plus 5 divided by 2, m will be is equal to that term, or m will be is equal to minus of root 13 plus 5 divided by 2, right? So we got the solution of the third quadratic equation, right? It is quite easy. It is also easy, right? There are around 7 examples are there in that particular exercise. I will solve next exercise for you. Sorry, next problem for you, right? There are the 6 number of problems are there, right? Okay, let's move towards now. Let's move towards problem number 4, right? Problem number 4, right? Okay, what is the problem number 4 now? We have problem number 4. Okay, I'll write down example number 4. So what is example number 4? That is nothing but a 9y square, right? This is a little different problem. I forgot to tell you that if this problem will be valid only and only if the square terms supposed to have a coefficient should be 1 in all the previous examples. Okay, I'll show you how it is. In all the previous examples, coefficients are in that particular problem. Just hold on a second. Okay, in every problem the square coefficient of x square, here it is 1, coefficient of x square again here it is 1, coefficient of m square here it is again 1. But right now in the problem number 4, the coefficient of y square means the square term, the coefficient is not 1. So what is our criteria to solve this particular problem? So first of all, make that coefficient 1 every time. So that is main thing. So because in the previous examples it was already available over there, so that's the reason why I am not just worried about that particular term. Okay, that particular quadratic equations. Now but in a fourth example, coefficient of y square, here it is 9. Now minus 12y plus 2 will be is equals to 0, right? Now we need to make the coefficient of the square term need to be 1. So here I want a 1. So what to do? Just divide by 9 on both sides. Divide by 9 on both sides, right? So you need to divide by 9 on both sides. So what to do? So 9y square I'm going to divide by 9, minus 12 by 9 I'm going to divide as it is, y plus 2 by 9 will be equals to 0 by 9, 0 it will be there. So 9 ones are 9, 9 ones are 9. So what will remain there? That is nothing but only y square, 1y square. That means coefficient, now we made the coefficient of the square term, that is equals to 1, right? Now minus 3 3s are 9, 3 3s are 9, 3 4s are 12. So what we got, that is nothing but a 4 by 3 y plus 2 by 9 will be is equal to 0. Now what is our next step? Now we got the coefficient of y square, or the coefficient of the square term, that is equals to 1. Now we wanted to shift this constant on the right hand side. So what I'm just going to do, I'm going to subtract this 2 by 9 on both sides, right? Minus 2 by 2 by 9. So add this to minus 2 by 9 on both sides. So what is our next step? So y square will be remain as it is, minus 4 by 3 y will be remain as it is. Now plus 2 by 9 and minus 2 by 9, it will be become 0. 0 minus 2 by 9, that is nothing but a minus 2 by 9, right? If you add any number to 0, if you subtract any number to 0, we will get the same number, right? So next term will be is equals to y square minus 4 by 3y will be is equals to minus 2 by 9. So we got the situation. What is this situation? Square term, the term whose power is 1 and constant on the right hand side. So if this is the ideal condition to take a coefficient of a uh, term whose power is 1. So coefficient of y will be is equals to what it is, minus 4 by 3. Coefficient of y will be is equals to minus 4 by 3. So we are going to do what we are going to do, divide it by 2, right? So by dividing, what exactly you will get? So 2 ones are 2, 2 twos are 4. So what it is there, 3 1 okay. So what we got, minus 2 by 3 we got. So what to do, take a square of this particular term and add on the both side of this particular equation that we solved. Right, so I'm writing that y square as it is, minus 4 by 3y as it is. Now I'm going to add some specific term on a both sides. So what that specific term that we need to add? So that is minus of 2 by 3 whole bracket square, that will add on both sides. So minus of 2 by 3 I'm going to add on the both sides. So what it is, this left hand side is a complete square. So what that square is, that is nothing but a y minus 2 by 3 whole bracket square. If we solve this bracket, you will get the same term, right? So that will be is equal to minus of 2 by 9 plus square of a minus 2, that is equal to 4, square of a plus 3, that will become is equal to 9. Now we got the solution. So what is our solution, right? So what we have, that I'm writing the same term, minus of 2 by 3 whole sorry, here we have 3 whole bracket square. Now simplify this particular, now denominator are same, then numerator are get subtracted. So 4 minus 2, that is equal to 2 divided by 9. What is this, what this term is, 4 minus 2 divided by 9. So 4 minus 2, that is 2 by 9. So for this particular whole term, what I'm just going to do, I'm going to take it plus 2 by 9, right? Now take a square root on both sides. So what is that? Take a square root. Taking square root on both sides. So by taking square root on both sides, so what exactly you will get? Taking square root on both sides, you will get, okay, I am now going to take taking square root, that is the left hand side is there, will be is equal to like this, plus minus, that is very important, plus minus square root of 2 by 9. Now square and square root term will get cancelled. What will remain there? Y minus 2 by 3 will be is equal to plus minus square root of 2 by 9. Now we are very close to our solution, right? So we want only y on the left hand side, so I'm going to do add 2 by 3. Again I'm telling you, if here is this minus 2 by 3, instead of minus 2 by 3, if it is there plus 2 by 3, then you need to add minus 2 by 3. Now here it is a minus 2 by 3, that's the reason why opposite of minus 2 by 3, that is plus 2 by 3, I'm adding over here. This plus minus root 2 by root 2 by 9 will be as it is, right? Now I'm going to add, oh sorry, we need to add over there. Which term you need to add? You need to add here on the both side. What you need to add? Plus 2 by 3 you need to add. Right now I'll write on the next term ladder. So y will be is equals to minus 2 by 3 plus 2 by 3 becomes 0, will be is equals to plus minus root 2 by 9 plus this 9 is in a root, right? 2 by 3 will be as it is. Now what is our next term, right? So y will be is equals to plus minus root 2 will be a remain as it is, root of 9 will be is equals to 3 plus 2 by 3 will be remain as it is, right? Now what to do? Y will be is equal to take a plus root 2 by 3 first, plus 2 by 3, or y will be is equals to minus of 2 by 3 minus of root 2 by 3 plus 2 by 3, right? So we will take a first plus sign first, root 2 by 3, and then we will take a minus later, right? Now denominator are same, then numerators are get added here. Denominator are same, then that's why numerators are get added. So root 2 plus 2 by 3, or y will be is equals to minus root 2 plus 2 by 3. So this is nothing but a solution for the fourth problem. Problem number 5 and problem number 6 I'll solve for the next session. But for the today's session, I'm just providing you homework on the basis of a completing square method. So for the today's session, let's stop here.